In number 33, one thing that is unique about 33 is finding the tangential acceleration, because immediately you might be thinking, based on what we've been doing so far, is that you will get it by A equals R alpha, because that's usually how we get it. But if you read the problem, at no place in here do they give us the alpha. We do have the R. If you look up here, we do have the R, the radius. The speedboat is negotiating a circular turn, and we know the R, but we don't have any information about the alpha, the angular acceleration, and they're asking for the tangential acceleration. So I'm actually going to get it going back to Newton's laws of motion, and we have a formula that F equals ma. And they're telling me that the net tangential force is 550 newtons, and I know what the mass of the speedboat is. So I'm actually going to get part A by just using the formula F equals ma. Now, since I'm looking for the tangential acceleration, I need the net tangential force, which is conveniently given to me in the problem. So the tangential acceleration is going to be the net tangential force. Remember, it's always the net, because that's what directly causes the change in acceleration. Why we did like applied force minus friction would be the net. We wouldn't just say the applied force equals ma. It was the applied force minus the friction. So if we plug in the numbers here, we get 550 newtons divided by 220 kilograms. Both of those are divisible by 110, so that's 5 over 2. And 5 over 2 would be 2.5 meters per second squared. So that is your answer for part A. Now for part B, they're asking for the centripetal acceleration 2 seconds into the turn. Now I've had a lot of people on the test. What they've done is they know the formula for centripetal acceleration is we've got a formula for centripetal acceleration that is v squared over r. So I know that if I can get those two numbers, I'll get the centripetal acceleration. I could also use r omega squared. That's another option. But some I've had on the test, what they've done is they say, oh, good, I got my r, so 32 meters. I'm going to put that down there. And, oh, I see 5 meters per second, so I'm going to put that in for the v, and that's going to be the answer. Well, 5 meters per second is the original velocity. We're looking for the, so yes, that would be the centripetal acceleration of the boat going into the turn. But the question is, what is it after the boat is 2 seconds into the turn? So I have to do that. Now remember, tangential acceleration is like the A that causes the change of speed. And so I know the time, I know the original velocity, and that's my A. So it's almost like doing a straight line motion problem, because I'm looking for the final velocity here. So that's what I need. So if I have that, then I'll be able to get the centripetal acceleration. So my A is going to equal the 2.5 meters per second squared. I don't really have to write it because I'm not really dealing with another direction. So, I mean, the tangential acceleration is the acceleration that's causing it to speed up or slow down. And then the original velocity is given as 5 meters per second. The time is given as 2 seconds. So it started at 5, and sometime later it's going to be more than 5. So we're looking for the final velocity. Because whatever that number is, that's going to be this number right there. Because we're looking, that's the v that's required to solve for the centripetal acceleration 2 seconds into the turn. So those are your facts. Our equation is Vf equals Vo plus At. Nothing's zero, so if I rearrange, well, I don't even have to do any algebra. Vf is the unknown. So if we plug in the numbers, Vf is going to be Vo plus At. So the original velocity is 5 meters per second. The A is 2.5 meters per second squared times 2 seconds. And that's going to be, well, 2.5 times 2 is 5. 5 and 5 is 10. So 10 meters per second. There's your final velocity. Now I've got the numbers to plug in here, and I'll have my centripetal acceleration. And this problem, I have put this problem on the test. I know it's on at least either the A or the B version of the test. So AC is going to be V squared divided by R. The R, I think, was 32 meters. And now the final velocity is 10. And that will give me the answer in meters per second squared. And that's like 100 divided by 32, so it's going to be 3 point something, right? 3.13 meters per second squared.